target is really just this bottom one because we covered all the rest yesterday. What just happened? Oh, I opened a new one and it didn't. Oh. Remember I got the pen's colors fixed? It didn't fix it on this one. Okay. I can write a linear equation from an application. So we're just really revisiting today. We're just doing word problems. So this is worksheet 3. And we're going to do number 1 quick. It says in 2010, a school population was 2,004. By 2020, it had grown to 2,624. Assume the population is growing linearly. What is the average population growth per year? Okay, how many people? What do we get? 620? Did I do that right? That's how many more people came, right? But per year means we need to divide by the number of years. And how many years was that? So what did we really just do? We found the slope. Good job, Antoine. Everybody get it? We just found the slope, really, right? We wrote this as an ordered pair, kind of. And then 2020, there were 26, 24. And then we found the slope. All right, what is the average population per year? We should probably label that students per year. I don't have a lot of room. I'm just going to leave it. All right. Can you determine what the population would be in 2000 if this pattern were to continue? Could we think about how to figure that out? Some of you can just do that logically. Eventually, I'm going to show you how to use an equation, but what do you think, Jada? What do you think we should do?
We should take 2004, the population times 620, because that was the population growth.
This is her idea. Follow this logic, guys. 2000 was 10 years before 2010, right? So we need to back up this population growth of 62 per year. We need to back that up 10 times. So start with the 2004 and subtract 62 10 times. Okay? We're going to do this with an equation in a second. Let's try to find an equation here. It says write an equation of the population, P, in terms of T, the years after 2000. Oh, years after 2000. Okay. So what did this come out, guys? Somebody did this, yes?
1,030.
Did anybody else get that answer? Okay. So we can write the equation right now. The population is growing at 62 per year, starting with 1384. Okay, let me show you how I would have done this problem real quick. I would have found the slope like we did right here. Oh, let me switch colors. I need to speed up a little bit here. I'm talking too much. Okay, m equals 62, and then I would have just done, like if it's going to say years after 2000, I would have called this ordered pair 10 years after 2000. The population was 2004. So then I would have used the point slope form. We're going to practice this some more in a minute. So 62x minus 620. And then I would have added this 2004 over the other side, and it would have become, was that, what does that say? 1384? Okay, so we could have used point slope to find this equation as well. All right, use your equation to predict the population in 2025. We got to be a little bit careful. We're not putting a 2025 in for years. We're putting what? Yeah, because it says after 2000, so we got to take off the 2000 and get t equals 25. And then we're just gonna type it in there. So 62 times 25 plus 1384. Anybody have an answer yet? 2934? No? 29? Okay, that's supposed to stay students. That's a big mess. All right. How are we doing? Let's try this same idea. Number 2 is a different equation, kind of equation. I'm gonna come back to that one. Let's try this one. Number 3, a gaming company charges a flat fee for access and then a certain amount per minute that a customer is playing online. If a customer plays 410 minutes, the monthly bill is $71.50. If they play 720 minutes, monthly bill is $118. Find the linear equation for the cost of the gaming plan as a function of X, the number of minutes. So we're doing cost equals number of minutes is, we're looking for this format, okay? So we have an X is number of minutes and a Y is cost. What are the two ordered pairs we know right now? 410 minutes costs $71.50 and 720 minutes cost $118. So can you figure out the slope? I'm not even going to write it down. Can you do it? 118 minus 71.50 is 46.5 on the top, and the change in X, 720 minus 410 is 310. That's a 0.5, sorry. Everybody get where I got those? I'm doing slope, I just divided. So then if I divide 46.5 by 310, I end up with 15 cents. Did anybody get 0.15? Okay, so that's how much it's costing for what? Per minute, right? We did cost per minute. So interpret the slope and intercept. Well, the slope is cost $15.15 per minute. All right, we're supposed to finish the equation though. So I'm going to go back and put in one of these points. I think I'll use this one because it doesn't have a decimal. I'm going to go y minus 118 from that point. I'm using point slope. My slope is 0.15, and then x minus 720. Can you fiddle around with that and get it in the right form? Did anybody else get a 10? Just for the intercept? Okay. So if we were writing it in the form they actually asked for, the cost would be 15 cents plus 10. Does anybody remember what the 10 meant from this equation? Gaming company charges a flat fee. So the cost is $15 a minute plus the flat fee of $10. Just, it said to interpret those. Now, we could put in 1800 minutes, just put it into the equation. I'm just going to skip that step. Is everybody good with that last one? That's kind of the point of doing these, is that you can make a prediction with them. But I'm skipping it. I'm going to go back real quick, I guess, and do number 2, or at least start it here. It says the Federal Reserves were at about 16 billion cubic feet of helium in 2015 and has been depleted by 1.4 billion cubic feet each year. Give a linear equation. Okay, they are already telling us what? The slope. The rate it is going down. So it says the reserves would have, the slope is negative 1.4 cubic feet per year. And it says, in terms of the number of years since 2015, well, what did it start with in 2015? 16. So that one was just fill the numbers into the equation because it gave us the starting value in 2015. Okay, and then it gave us the rate or slope here. I don't want to make that look like a division. That's right, rate or slope. Rate is a slope. Okay. This one you would put in what number, guys? From 2015 to 2021 is 6 years. Anybody type that yet? What'd you get? A little louder? 7 point. And it's billion cubic feet. If the rate of depletion doesn't change, when will the Federal Reserve be completely depleted? What is that asking us to do? Yes. So 0 equals negative 1.4x plus 16. If we divide, we get 11.4 years. If we add that to 2015, according to this, we would run out of helium sometime during, I'm going to say, 2026. You doing all right? All right, I am going to set up this number 4. Read the question to yourself and try to set some kind of an equation up. Or think about how we might set up an equation. So it says we want to make option A earn a larger income than option B. Can anybody write an expression for option A? I love it. I probably would have written 25,000 plus 0.15x, but doesn't matter. It's the same thing, right? You're starting with $25,000 and they're adding on 15% of your sales. Would everybody have remembered that percent means you got to move the decimal over? Okay, to get rid of that percent symbol, we have to move the decimal back twice or divide by 100 because this means out of 100. All right, we want that to be greater than, what's the other side going to say? Anybody? 5%, be careful, yeah. Okay, can you guys solve that real quick? Whoops. Let's see if I subtract. it 80,000 or 800,000? Did I move? It's just once, right? Did I do something wrong? 80,000? Okay, that's what I got. So you'd have to sell over $80,000 in internet service a year. In order for that option to be a better deal. Does that seem okay? I like that kind. Those are easy. Fortunately, I don't think that's what's on the quiz. There's only one of these on the quiz, and I think it's like, it's very much, if you want to mark it down, it's very much like this number 3, okay? Number 3 would be what, like what's on the quiz. All right, number 5 is a cool question. It says, the median home values in Mississippi and Hawaii adjusted for inflation are shown. If we assume that the house values are changing linearly, find the rate of change for each of these 2 states. I'm just gonna do Hawaii to save time, okay? You guys can go back and do the other one. But we need to decide, it doesn't say what to use. Do you wanna use the actual years? Let's just use the actual years this time. So we'd have 1970 and Hawaii is 87,400. I'm just writing it as an ordered pair for my own benefit here. And 2010, 304,400. Big numbers. Okay. So find the rate of change means to find what? Slope. So we're going to do y minus y on the top. My handwriting is just really messy today. I'm sorry, guys. And so in Hawaii, 304,400 minus 87,400, the price of a home went up $217,000 over the course of 40 years. Did anybody else get 5425? Okay, so that is the increase per year. If these trends continue, find the median home value for each state in 2020. So we need to come up with an equation so that we can predict this. Yeah. Yeah, we don't, it depends what we're going to use for our starting value here. Do we want to use year 0? Do we want to use, we could actually kind of trick the system here. And we could call this the starting year or this the starting year, right? So otherwise, if we wanted to, we could use the whole point slope thing. I think I'm going to write that down. I'm going to show you, because it didn't ask for the equation, right? Okay, so I'm going to write, I'm sorry. I am going to write, okay, I'm going to write y minus 87,400 equals 5425 times x minus 1970. So I just put this into point slope, because I could. And then where do I need to put this value? Is that an x or a y? We used years as x, right? So I'm going to put in for x 2020. You don't have to do it this way at all. I was just showing you that you don't always have to calculate out the whole fancy equation. All right, now since this is just solving an equation, I could subtract in there and I would get, what is that, 50 years? And then we're gonna add over there the 87,400. Move it onto that side. 5425 plus times 50 plus 87,400 is a whopping 358,650. Don't you wish you bought a house in Hawaii in 1970 and you could sell it today and make a fortune? All right, I would just keep it. I would love to own a house in Hawaii, but all right, was that the last one? Okay, I'm gonna stop the recording.